Ooh. Oh no. Oh, okay. Is it? Hello? Okay, shut. Hello. I don't know if I'm actually live or not. Yay. Am I live? Oh, good. Okay. I'm actually live, but I somehow set up 2 streams, so I've got to cancel the other one and try to get people to pop over here. So I'm typing in the chat. So I'm gonna kill this, maybe, hopefully, and then I'm gonna go to my studio and try to delete a thing. Holy crap. Hi, everyone. I am, oh, good. Okay, that's not helpful. I don't know how to stop the other one, but okay, yes, this will end badly. Hello, everybody who's here. I'm super glad you guys are here. I'm just gonna be live here and hope the people that were on the other stream figure it out. Cool. This is my first live stream, and I'm a little nervous about it, but I want to get some of the bugs and whatnot worked out today. Because on Saturday, thank you, Dora. I'm gonna just let the other one be for now and try to not panic about it. Anyway, okay, cool. People found me. That's exciting. So Saturday, I'm gonna do a 1K sub live stream thing. I've got Skylar from Skylar Fiction and Dr. Josh from Digital Hammurabi. They're definitely going to be on. So hopefully it'll be like Maddie and Friends celebrate me hitting 1,000 subscribers, which I'm super stoked about and very, very grateful to everybody who's here, everybody that's been subbed for forever, and all the new people that found me after the Fight the Flat Earth chat or my debate on Modern Day Debate with Nathan Thompson. Okay, so all of that. Oh, I have one more other piece of exciting news before we jump into, we're going to talk about Dr. Andrew Snelling today. And I'm a little mad at our friend, the creationist geologist, and I'll let you guys know why here in a second. But my other piece of exciting news is I got my Fauci ouchie, my second one, right there today. So far I feel fine. I got it at like 9 this morning, so we'll see how I feel tomorrow. But I didn't have any side effects with my first one, so fingers crossed. But I'm very excited, and I'm also very grateful. Out here in Oklahoma, the Native tribes have really, really stepped up and have been vaccinating lots of folks. So I got mine through the Osage Nation, and it was great. It was just a great experience. So, okay. That's not what you guys are here for, though. You guys are here for me to talk about Andrew Snelling. Thank you. Thanks, Creation Miss. I'm kind of, this week is just like shot for me in terms of schoolwork. Um, okay. Round 2 felt like a mild flu without the sniffles part. Okay. I did immediately come home and sleep for like 2 hours after the vaccine, but to get to the place where they had it, you have to be over the 60 to get it. That kind of, I'm super lucky. The tribes have really been stepping things up, which has been great. So right now in Oklahoma, actually, I think starting in early April, anyone 16 and over can get their vaccine. So yeah, yay vaccines, yay science, yay vaccines. Okay, cool. Let's get into our friend Dr. Snelling. I did figure this part out. I can switch it, which is cool. Okay, so the reason that I want to bring up Dr. Andrew Snelling, and this is a whole series of his over on Genesis on radiocarbon dating. But the reason that I wanted to bring it up is because there was something he said in the video of his that I reviewed, and he said that they found radiocarbon in coal. And so when we get to that claim in here, I have feelings about it that I want to talk to you guys about. So let's press play on this sucker, and I'll keep an eye on the chat. Can you guys hear the audio on your end? If you cannot, please let me know. That might be a thing I messed up, because I'm learning StreamYards on the fly. Yeah. This is such terrible 90s music. No audio from the video. Okay, let me figure that out. Okay, I'm gonna try to stop sharing that from StreamYards for right now. And I'm gonna, you have to share in Chrome. Oh, okay. Yes, okay. So, okay, I'm gonna click this button and I'm gonna share screen and to share a video with audio. Oh goodness, okay. Okay. I think I can do it. Share screen, Chrome tab, share audio, this button. Oh my gosh, thank you guys for being my live tech support. So let's see if you can hear the really bad 90s sitcom intro music. No. Okay. Hey, Dapper. Okay, are you guys getting the audio now? Okay, yay! Yay. Oof. All right.
Let's start to define some terms, and so that you can understand this subject about radioactive decay and the basis for radioactive dating.
Okay.
Every element, whether it's carbon, oxygen, hydrogen, is made up of atoms.
Oh, we know all of this. We know what isotopes are.
Or just radioisotopes,
and they radioactively decay. This is just fine.
And that's the rock's age.
Okay, so here's a fun claim that they bring up a lot. Oh, that's not the button I want. Okay, I'll figure that out later. So yeah, they use this hourglass analogy quite a bit. And I think this is like kind of intentional, because like an hourglass isn't, because what they're going to say, so the idea of the hourglass, right, is, oh, hey, parent isotopes decaying to daughter isotopes is like an hourglass where the top sand falls into the bottom sand. We lose this and we gain this. And hi Gutsick, hi Erica, and TD Lane and Dapper. I'm so glad you guys are here. I really appreciate it. So they like to use this analogy, and I, on the one hand, like for the very basic level of how radioactive decay works, it's not so bad. But then they use that hourglass analogy and I'd be like, but you could tip the hourglass over. You don't know if sand was added. Like you can really easily point out problems like with the analogy and then claim that these are problems with the actual science. And that's just not real. That's so not real. Definitely a good question. Why are many so Aussie and Kiwi YECs? My theory is just that we as Americans love accents, and therefore, ergo vis-a-vis, we like reward we reward their accents. Yeah, but Scandinavian metal bands are amazing. So, okay. All right, so let's get going. And I wanted to specifically talk about carbon-14 because that's where I have
included
feelings.
on the screen there.
Okay, so he's just talking about that thing. And now let's let him talk a little bit.
Years, groundwater flowing through the rock added lead or washed away uranium.
Okay, that was uranium lead dating. Oh, goodness, good. That's my dog Shep in the background, if you can hear him barking. Yes, so groundwater can't remove uranium from zircons. That's why you use uranium lead dating for specifically. That's why we use zircon specifically, because they're so robust and so resistant to weathering. I like that I paused it for about 5 seconds and already could point out a flaw in his argument.
You'd never know for sure whether your rock has remained uncontaminated for millions and millions and millions of years. Now, you can understand it's a wide sweeping assumption. I mean, it's like with your hourglass. Little did you know while you were out doing the laundry, your mischievous 13-year-old came and lifted up the lid and put some more sand in.
Don't you I predicted that like 2 seconds ago that he was going to say that. And he's really not understanding zircons, or I'm about to be comfortable saying intentionally misrepresenting them. But let's keep listening.
He contaminated your clock, and you thought you had been going for half an hour, but actually you've been going for 40 minutes. You see what happens? If it isn't a closed system that can't be contaminated, you can't use that clock accurately. And thirdly, obviously, you have to know the rate of radioactive decay. It must have always been constant at today's measured rate.
And again, this is an assumption that's brought up a lot about isotopes and radioactive decay. The decay constant, no matter what we do to the decay constant, right? No matter what we do to any radioactive material, we have never gotten that decay constant to change. So if you, good sir, if you, good sir, can prove that you can change the decay constant of a radioactive element, please go collect your Nobel Prize, because that would be the level of discovery that really is. And I brought up T.D. Lane's comment here because absolutely, he is a geologist. He knows full well how zircon isochrons work. Zircons are a very special mineral, and there's a reason that we date them and not other things, right? Because zircons are special. They're resistant to weathering. They're formed in a way that doesn't include lead. The uranium's not gonna get washed away by water, for crying out loud. That's just not gonna happen. And he's a geologist, and that's what's driving me nuts. He knows this, right? He has to know this. So that's I'm getting a little upset with our friend Andrew Snelling, Dr. Andrew Snelling, because he has that PhD in geology, I have a higher expectation for his level of knowledge. I do not have a PhD in geology. I took one geology class as an undergrad, and I understand this stuff, right? If I understand it, he absolutely does. And so I don't know what to say other than he's knowingly being deceptive, and that makes me angry. Like, I will attribute to, I try to attribute, what's the word? Don't attribute to malice what can be attributed to ignorance, right? I try to keep that in mind, but like, I don't think this can be attributed to ignorance.
Now, the scientists have only been measuring radioactive decay for the last 100 or so years. It was only discovered just over 100 years ago. And so they've taken...
And in 100 years, we have never managed to measure a different decay rate. So What, or 150 years. So like, what more do you want, my guy? Goodness. Okay. Let's skip ahead because he's making me feel salty already. I want to get to this radiocarbon
So the
dating.
question we should ask ourselves, if there's a matching of the relative order with the millions of years ages, which are highly inflated, of course, compared to the biblical timescale, we have to ask ourselves, why should radioactive decay rates have always been constant at today's measured rates? Why should?
Because some things in nature are constant, and that's just the way they are, right? Like, oh my gosh. Okay. What are we going to get to? Oh, that's
that be an assumed constant? What if radioactive decay had changed in the past? If it had, and the clocks tick faster, then we couldn't use them to measure the ages of rocks.
What if unicorns were real and instead of, I don't know, gravity, everything's held together by glitter and friendship? That's the same degree. That's you can say what if all day long, but like if there's no evidence or data to support that claim, then you might as well be waxing poetically about unicorns.
Well, I was involved in an 8-year project initiated by creationists called the Radioisotopes and Age of the Earth Project, the RATE project.
Oh, and you concluded that a constant decay rate is absolutely false. Okay, so where, good sir, where is your Nobel Prize? And especially if you concluded this, in 2015, 15 years ago, that's surely long enough for it to be accepted by the scientific community, right? If you've shown your data and published your research, right? Rate said they need miracles for seriously. Oh my goodness. We got the YAC like heavy hitters in the chat with all these lovely people. Oh, hey Melvin. Okay. I clicked a weird button here. Okay, cool. Nope. Did I jump to the... Okay.
That demonstrate that radioactive decays must have been grossly accelerated during one or more recent catastrophic geological events, especially during Noah's flood.
And there's still no evidence that like Noah's flood actually happened. So like if you're starting with the assumption that Noah's flood is real, there's so much of this that's just bad science, and that's driving me absolutely bonkers because he's touted out as like their go-to scientist. Yeah.
Now,
okay.
That makes sense. If we had catastrophic rock formation and other geological processes during the flood, why not catastrophic
rock formation? Please explain to me how you make marble catastrophically. Please explain to me how you make granite or any form of continental crust, anything that's not a basalt, right? How do you make that catastrophically? So I don't know, maybe I need to do a scripted video on like how to make rocks because this is not how, right? Like there's certain types of rocks that take a very, very, very catastrophic limestone. Okay, but the whole earth isn't made of limestone. Right? The whole earth isn't made of limestone. The earth is made of lots of different types of rocks, like marble and other things that aren't going to be formed catastrophically, things that have to be formed slowly. And some things can form quickly and some things can't, and different words mean different things. If I can believe it, it deserves equal time. I want to publish a paper about unicorn farts powering, I don't know, nuclear reactors just for, oh, sorry, I misunderstood. Sorry, Dapper, I misunderstood my geology knowledge. You guys see the limits of my geology knowledge. There's not a whole lot of it. Yeah, okay, yes, absolutely. All these rocks, how in the world are they going to form catastrophically, my guy? How? Please explain to me the process.
It's of radioactive decay.
No, what? Because I can pretend that rocks can form quickly, therefore radioactive decay can change rates? What sort of nonsense is this? By the way, I really don't know the rules on this, so I probably shouldn't, but I'm going to anyway. I'm drinking one of my favorite beers right now, because it's called Bearded Theologian, right? And I thought it was appropriate. Yeah, I thought my Bearded Theologian beer was appropriate for tonight. Okay. Let's get this. Like, I feel like I need to stretch.
So if that's the case, and the clocks tick faster in the past,
which they don't.
Radioactive dating cannot be used to accurately give us the absolute millions of years ages that are claimed.
And like I don't know why they always just say millions of years. Like, the Earth is 4.567 billion years old. Billions are different than millions, right? By a lot. Turns out, whole 3 orders of magnitude.
For the rocks. Well, let's look at these evidences. Number 1, helium in zircons. Zirconium silicate is a little mineral called zircon. And in zircon, these zircon grains, they contain uranium. They're highly radioactive. And as a result of having the uranium. And as the uranium decays, a byproduct of that decay.
Okay, yeah. So helium and zircons, it's the uranium decay chain down to lead. It has a lot of alpha decays. I think it's entirely alpha decays. There might be some betas. I'm forgetting the decay chain off the top of my head. That alpha decay, an alpha particle is just the nucleus of a helium atom, and helium diffusion, right? So that helium is formed, it's a gas, and it's going to like escape from that crystal, right? And what's very cool is that scientists can in fact use they can take like a zircon and like basically force the helium out of it, see how much helium is in it, and that tells you a lot about like the thermal history of that mineral. But it tells you much more about what temperature of environments it's been in than it does like how old it is, because diffusion, guys, that's the same process by which, like, if you pour a bit of milk in your coffee but don't stir it, right? How long will it take for that milk to diffuse through your coffee? But I love Star Trek. I'm going to get so distracted by the chat. I would sometimes much rather talk about Star Trek than young Earth creationism, but that's because Star Trek is a delight and young Earth creationism is dangerous. Okay, so so that helium, it's going to diffuse out, so just sort of move randomly and spread out. And the hotter it is, the faster that happens. So how much helium you can like force out of a zircon will tell you a lot about the type of thermal environments that zircon has been through. So you can definitely learn stuff about it. But the fact that there is helium in zircons he's going to claim that means that like, I don't know, probably therefore God. But like he's going to say that this means therefore, ergo, vis-a-vis, there's too much helium. It shouldn't. I would die, but anyway, okay. They're going to say that there's too much helium. It should have all diffused. So therefore, ergo, vis-a-vis, these zircons have to be like younger than like we think, right? Younger than the uranium lead dating says, but it's really nonsense. It's been very, very thoroughly debunked. Like if you even Google, like it took me forever to find a paper that dealt with helium diffusion in zircons in a non-creationist journal. Like it took me a long time to get to that, whatchamacallit, the actual journal where it talked about the thermal history of the minerals, because the only people that talk about this or are worried about it are young Earth creationists. Like, but it's just not. yeah, and that's why I'm here, because I think young earth creationism is dangerous, and why we need to respond to their arguments. I think that's important. I'm mostly here to bring like good science to the internet, and I think sometimes that means pointing out bad and manipulative science. Okay, so there's like so many videos in this series. Yep, that's fine. Okay. So let's jump to the second one and try to get to the carbon dating.
Geothermal energy in the Los Alamos.
Okay.
That graph. Now,
this is all helium.
Now, when most geologists do their studies, they only...
So let's take a peek back at this slide. 4 major radioisotope dating methods used on rocks are potassium to argon, rubidium to strontium, uranium to lead, samarium to neodymium. The fourth one that's one I'm not familiar with, but the other 3 I've definitely heard of. And basically you just use lots of different clocks and see like where they agree. So like if we can measure this age using completely independent methods, and all 3 of those decay chains are completely independent, and then they all agree on the age, that's a really strong evidence that like that's the right. It's Dapper, I'm going to type it in the chat if you can't see it. To neodymium. NIUM. There we go. Oh yes, gosh, that's why I know of samarium. It's a great shielding material for neutron capture. It's great for nuclear reactors because it'll capture neutrons. That's why I've heard of that before. Yeah, I keep wanting to pronounce it Sumerian too, because I've been God damn it, guys. My ability to read puns. Look, it's not great when I'm talking to people in person. I don't always get sarcasm. But it's even harder in chat. Anywho. Yeah. That's it can be used as a poison, that's the word, a poison in reactors to like absorb excess neutrons. It helps extend the lifetime of nuclear reactors. Okay, what does he have to say about I heard him say something that was like, most scientists do this, so I'm intrigued to see what he thinks most scientists do.
The 4 major radioisotope dating methods used on rocks are potassium to argon, rubidium to strontium, uranium to lead, samarium to neodymium. Now, when most geologists do their studies, they only ever use 1 or 2 of these methods on their rock samples. Why? Because they say, well, whatever clock we use, we should get the same results. Whether we use the uranium method or the potassium method, it doesn't matter.
So that's true because it's been tested. Right? It's not just like we assume all this stuff. Yes, I love it. I also love that like the US Navy owns, I think, all the hafnium in the world. Anyway, so it's not that like scientists or people who do dating methods for like their job, right? It's not that they just like assume that all these methods are going to agree. It's that these methods have been tested and they do all agree, right? So now we know that. So now we can use these methods like independently. Not every lab can do every dating method, et cetera, so forth, right? Like funding matters, and so if we know, because we tested, that all 3 of these methods are equally valid, then we can just use one, right? And not go through the expense of, hey, let's date all 3. No, maybe you would use all 3 methods if, say, it was, what's the word? It was inconclusive, right? Or you wanted to maybe be more precise. or something like that. Or you were concerned that your sample had been contaminated in some way. Like, so there's reasons to use multiple tools. But he's saying that like, oh, they think that these should all agree. And so they assume that they do. Like, that's not, no, good sir. That's not what anyone's doing. Okay.
Because the rock only has one age, and these clocks are all supposed to agree with one another. Therefore,
if you just saw me jump out of my skin, that's my dog Shep barking. I'm gonna go with grass in the backyard.
they should all use the same ages, and so they only ever do one or more dating methods on the same rock samples. And if someone ever wants to repeat the work, they usually collect different samples to use a different method. So we said, okay, we'll get smart. We'll use all 4 methods on the same rock samples to really see whether these clocks agree with one another. And we also use the superior isochron method that I talked about earlier. Why is it superior? Because instead of using one sample, you use 5 or more samples. And in many of our studies, we used up to 20 samples so that nobody could accuse us of being light on with data. And that's very important. The more data, the more ability.
Yes, grass is a huge threat. Somebody's mowing their lawn. Shep is against it. Shep is against it, guys. Okay.
To get tighter statistics in our results. And that's exactly what we found. So I want to show you 4 rock units from the Grand Canyon. First of all, there's this rock unit where the molten rock was squeezed like toothpaste between sedimentary rocks. It's called a sill. And the rock is a diabase, which is like a basalt. And these are the results that we obtained. The potassium argon result was 841.5 million years. The rubidium strontium, 1,060 million years. The uranium lead was 1,250.
Okay. Okay. Yes. Thank you. Thank you, TV Lane. Yeah. So there's these. I haven't read this paper. I'm just doing a live react, right? So yeah, definitely improper sampling. But let's like, even if we just gave them the benefit of the doubt, right? And here's including failing to separate volcanic glass from rock. Yeah, those would date very differently, team. But let's just point something out, right? Like, these are ages of, yeah, okay, so like 841 million years or a billion years, or 1.3 billion years. So they're not exact, right? But they're all certainly like, it's not that they could have been made 5,000 years ago, right? And this is something that comes up a lot with when they talk about like ages of old things, right? You know, when I say that like the age of Earth is 4.5672, 4.5672 billion years old, right? That means, and we like the age of the Earth and the age of the solar system is something that like, oh my gosh, that gets dated all the time, right? There's lots of different samples. We really try to get that like very precise. So, but the error is on that too, right? So 4.5, that's on the order of, I can move decimals in my head. 100,000 years? Sure. Yeah. So let's say that like, yeah, that's on the order of the 100,000 year mark. And so, yeah, you could be off by say like a million years, right? But that's not that big of a deal when we're talking about things that are 4 billion years old. So just because the error is like big compared to how long we live, right? Like a million years sounds like a lot, but it's not like it could have been today, it could have been a million years ago. No, it was 4 billion years ago, plus or minus a million years, right? Anywho, So yeah, so error ranges. That's something they harp on a lot, that like the older something is, the larger the error is. But it's like it's the percent error that matters, especially when we're talking about big numbers. So this seems like a silly point to get hung up on, right? Just because big numbers are big. But oh well. Okay, so let's skip ahead a little bit. What's their these different methods? It's fine. I don't want to talk about this anymore. I want to talk about I want this video to not be full page. That's what I want.
Potential geothermal.
Okay, I want to talk about, here we go. See, I want to talk about radiocarbon dating is what I want to chat about.
Abundant fission tracks. Now, what on earth are these?
Oh, nope. We're not talking about abundant fission tracks. We're also talking about the radio halos. That's like a whole conversation in and of itself. So let's jump ahead here.
100 million years worth of uranium decay.
By golly, he promised me radiocarbon dating in the title, and we're going to find it, team. Anyhow, okay.
Because you're all radioactive with radiocarbon.
Radiocarbon, we found it. Yes, we are all radioactive with radiocarbon. I think the potassium is more noticeable, but yeah. Like, I don't even have the energy to talk about this tonight. I am here. I am mad at him about claims he's made about radiocarbon dating, and I want to talk about it. So we're not going to get into polonium halos or any nonsense like that tonight. We'll save that for another day.
Now, think about it. As your body then, you go on living, the carbon-14 that you took into your body decays away and returns to nitrogen-14. And as long as you eat more food, you're going to get more radiocarbon, aren't you, to replace that which is decaying away. But your great-great-great-grandmother, when she died, she stopped eating. So since her bones have been in the cemetery, she's got less and less radiocarbon in her bones because it's kept on decaying back to nitrogen-14. So it's quite simple. If you want to know how long, whether the tombstone is correct in when she died, you measure how much radiocarbon is in her bones and compare it to the amount of radiocarbon in your bones. So
not a bad, like, science communication level explanation, right? Except that, your great-great-great-grandmother hasn't been dead long enough for there to be noticeable decay. The half-life of carbon-14 is what, like, it's about 6,000 years. Like, it's 5,700 something. Let's just call it 6,000, but just between us friends, we'll round it. So, like, I don't think it's very reliable. Like, you need to have enough time pass for enough carbon to decay for it to be measurable, So I think you need at least like 1,000 years. Yeah. Also, yeah, absolutely. Worms and stuff could screw it up. So anything that's going to reintroduce carbon into the system. Yeah, because you want to measure just the carbon that was in the thing that died, and not carbon from any other source. Okay.
And the difference, how quickly radiocarbon decays, you can calculate how long ago she died. That's how the method works. It's really quite simple. But here's the interesting sidelight to this story. As I said before, the equipment that is used today is so powerful that you can actually count individual radiocarbon atoms, carbon-14 atoms. However,
okay, so that you can go back to 95,000 years. Our carbon calibration curve is only good until about 55,000 years. So by measurement, sure, you could get back that like 60,000+ years, but you need the calibration curve for to know how much carbon it started with, how much radiocarbon it started with. So you can't really accurately measure back 95,000 years because your like initial condition is going to change and we don't have a good curve for that far back. Okay.
The detection limit is as good as 0.001% of the present level of carbon-14 which is equivalent to 95,000 years. That's right, you can only go back, theoretically, you can only go back 95,000 years with radiocarbon. You don't date fossils at millions of years with radiocarbon. The reason is that radiocarbon has a
I'm not taking that
half-life
bet because he's going to.
of 5,730 years. And it means that any ancient organic carbon conventionally older than 95,000 years, like dinosaur bones, should contain no detectable radiocarbon. Let me put it another way. If every atom in the Earth was radiocarbon, within a million years,
Dr.
all have decayed
Selling.
away.
We've heard this argument. Yes. Skip ahead. Can we skip ahead like 5? Yeah, so by a million years, by 100,000 years, all the radiocarbon should have decayed away. And his gotcha coming up is going to be like, but we found radiocarbon in coal. Anywho, let's find out.
We find dates, radiocarbon measurements on fossils that are supposedly up to 500 million years old.
Okay. This is the thing I'm mad about, team. Okay, can I make myself a little bit bigger? Oh, that's not necessarily helpful. Okay, so I think it was his rate research group that did this. And this was in the video that I covered like a couple weeks ago, where he talked about finding carbon-14 in coal that was like several million years old. And so here he's still using, what is it? He's talking about carbon-14 measured in biological samples up to 540 million years old. And here is, look, we found carbon-14 in them. That's what he's saying with this plot. And this team, this is why I'm mad. Because I think he's lying or in being intentionally dishonest here. So it is possible to like reintroduce carbon-14 into like coal or a diamond or some sort of like dead sample. So by dead, I just mean not bringing in more carbon-14. That is possible, but what's much more damning here is the way that those carbon-14 ratios are measured. If you guys have wondered what I did with my weekend, it was reading papers on this. Okay, so how do y'all think that carbon-14 is measured in these samples? You think it's a mass spec? You think they actually identify number of atoms? Because that's what I thought when I took the dear doctor here at his word. That is not how they measure it, team. That is not how they measure it. The way they measure it is by the radiation. So they measure the beta particles coming off, right? They measure how much beta radiation is being emitted by the sample. Gah. Yeah. Count the protons. Count the protons and divide. So you guys know why that means Dr. Snelling here is being dishonest? Because guess what else beta decays? Guess what else beta decays, team? Potassium. Potassium-40 beta decays, and it has a much longer half-life. Potassium-40, so potassium-40, that is why bananas are radioactive, right? So potassium has such a long decay rate, long decay constant. It should be beta minus. Yeah. I don't have any bananas on me. I have some plantains, but I don't think they're nearly as radioactive. Anywho, potassium-40 contributes to what's known as background radiation. So over the time span of these samples that we would look at, right, things that are up to 60,000 years old, right, it's the decay from the beta particles that you get, that background radiation, is constant from the potassium to argon decay, right? And so you can just subtract that out from the beta particles from the beta minus decay of the carbon-14 you're trying to measure, right? So when he says that they find this radiocarbon in fossils, and on the previous video of his that I did, when he said, oh, we found the same levels of carbon-14 in these two coal samples that were millions of years difference in age, guys, he wasn't measuring radiocarbon, he was measuring potassium argon decay. And he has to, I have to believe he knows that, right? Like he has to know that, right? So I know I'm so worked up. I'm so mad. I'm so mad. And I'm mad because I was a little gullible here. When Dr. Andrew Selling said, we found carbon-14 in these coal samples, I was like, okay, how would you get carbon-14 in those coal samples? It didn't even dawn on me that he was misrepresenting his findings, right? And he so is, because they were not Tesla Ranger. I get your sarcasm. I deeply appreciate the notice, the /S there. That's very helpful for me. I don't always get it. Because they're counting potassium decay and saying it's carbon-14, and they, like, surely they know better, guys. Surely they know better. Good. I'm so mad at this. Okay. All right. Let's let this video play a little bit, and I'm gonna have a drink, and I'm gonna drink some of my theologian beer and let Shep back inside. Gosh.
And they all have radiocarbon in them.
Do they?
Why did they never tell us that in their textbooks? In fact, they're all young. They're not 500 million years old. So you see, I was mischievous a little while ago, and I decided I'd collect some samples and send them to a radiocarbon lab. But I didn't tell them how old the sample was, so I sent them a piece of fossilized wood from a 189 million year old rock in England. And guess what? It returned a radiocarbon age of only 24,000 years. I took a piece of coal from Australia that's only 250 million years old, supposedly. It gave an age of 33,700 years. And I went up to Northern California and collected samples of ammonite shells with fossil wood next to them. Okay? And these are supposed to be 112 to 120 million years old. And look at the radiocarbon.
You can't date shells with radiocarbon, right? Like, am I taking crazy pills? Have I lost my mind? Like, aren't shells that's a very bad thing, right? Because something about ocean gosh, I should not try to science off the top of my head, but I think shells can be a no-no, like a known thing that radiocarbon is not a good tool to measure the age. I feel like I remember that somewhere in the back of my head. Okay. Let's let him talk maybe a little bit longer.
The wood and the shell almost match one another. I had 4 samples like this.
Oh, did you hear that, team? The shells and the wood were almost the same age, possibly because you were measuring the constant background radiation. Thank you, Dapper. Thank you, good sir. But again, God, you measured these things using the wrong tool, knowing that you were measuring beta decay from potassium and called it carbon, and are surprised that you got the same value, right? Because it's a constant background radiation. And and you're also surprised that it got in the range of measurements that carbon-14 is able to give you, right? Like, you used the Okay. Okay.
And some of them were almost exactly the same, in two different materials. So what we did in this rate project,
Potassium.
we decided to take coal samples from different parts of the United States that are stored at Penn State University by the US Department of Energy. And here's the samples. 3 of the samples were...
He's going to talk about coal, but we know what's happening here, team. We know what's going on. We're I'm so worked up. I'm so mad. Here's what's gonna happen, guys. He's gonna measure these coal samples, be like, look, I found radiocarbon, and we're gonna be like, no, you didn't. No, you didn't. You found potassium is what you found. And then you're gonna measure all of these to be about the same age, and it's gonna be younger, right, than the millions of years. But it's going to be nowhere near the 6,000 years that you need, right? And all the ages are going to be close together because you're measuring that constant background radiation. Let's see if I can predict the future here. Let's see.
From coals that are supposed to be 34 to 55 million years old. 3 of the samples were from coal beds that are supposed to be 65 to 145 million years old, and 4 of them were from coal beds that are supposed to be 299 to 318 million years old. And you can see they've come from a wide distribution around the United States. And guess what? They all had radiocarbon in them. In fact, they all had about the same amount of radiocarbon in them. They were all about the same radiocarbon age.
They were all about the same radiocarbon age. Why do we think that? Yeah, okay, yeah, because you're measuring potassium. Is the energy of the electron the same if it comes from potassium-40 or carbon-14? Off the top of my head, probably not. But I don't think, I think you're measuring, what is it I think you're measuring? I think you're measuring not the energy, right? I think you're measuring like number of electrons in some way, but I definitely could be wrong. But my point is, I think in the method that you like are measuring that background radiation or measuring that radiation, the beta radiation coming off. So if it's probably not, you're probably not able to distinguish between the 2 different energies. It's probably like counts, if that makes sense. Thank you. You guys are being amazing. I deeply appreciate the live fact checking. You guys seem a little calmer than me tonight. I don't know if that's real life. Okay. Oh, good. This is just, what in the world is this graph? Number of samples and percent modem carbon. So this is just, we have samples and, okay. I don't, sorry, you just threw this bar graph up here and I'm not entirely, you and me both, dude. Gosh. Amen. Okay. Sorry. He's just like, here's this bar graph, and I'm not quite sure what we're supposed to glean from this. I think it's just supposed to look impressive.
Surprise, surprise. Where did all these coal beds form? Right, during the flood.
Oh, right. We made coal beds during a flood. Goodness gracious. That's a thing that can happen. Like, gosh. Gosh, I'm so mad. Okay.
Flood. They all formed in 1 year. All these trees lived just before the flood. Would you expect to give you the same radiocarbon age? Absolutely. Whether they were supposedly 300 million years old or 40 million years old, they gave the same radiocarbon age. Isn't it great to be a creationist, as my good friend John Morris used to say? Well, we went further. We also took diamonds.
All right, more. Oh my gosh, look, diamonds. Those shouldn't be old. They also notice he didn't get like, he hasn't even said, I think the youngest age he said was like 30,000 years, which is still not 6,000, right? So even with all of this dishonesty, amen, good sir. That would actually be a fun video. Yeah, okay. Sorry. He's gonna say stuff about diamonds. Oh, guys, other YouTuber like accomplishments. Not only has someone slipped into my comment section just to call me a dumb bitch, you know, so I've made it there. I also had somebody slip into my comment section to try to convert me to Christianity. So I feel like I've made it. Anyhow, okay.
Are made up of carbon to see if the diamonds would have.
Ugh.
Because diamond is the hardest substance known and it's impervious to contamination.
Impervious to what sorts of contamination, good sir? Contamination by water? What about cosmic rays? Like, seriously? Come on, man. Come on, man. Okay. Ooh. If turning a foe into a friend, no. You're just saying it so concisely, TD Lane. I love it. Yeah. Turns out things radioactively decay. Thanks, dude. Yeah. Things radioactively decay. Uranium radioactively decays. Lots of things deep in the earth are radioactively decaying and spitting out high energy photons. So even if, so this is where I went when I thought he was being like honest, when I thought he was honestly saying that they found radiocarbon, my immediate thought went to like, oh, okay, well, how would radiocarbon have gotten in there? And my just immediate thought was, well, the nitrogen that carbon-14 decays back into is probably hangs around because nitrogen's a pretty like big molecule, you know? It's bigger than the carbon around it, so it might have trouble moving around. And so if you hit that with a high energy photon, you can get back to carbon-14. So that's also a possibility, but he's not going to talk about any of that shenanigans. And I have two very sweet, very big doggos. One is a bear of an Australian shepherd. His name is Shep. He's the one that was barking, and he is currently on a diet, but I think we've got him back under 100 pounds. So he is a bear, and a snuggly bear at that. I would love a blink dog. That would be a delight. But alas, alack, there's not nearly enough magic in my life. Yeah, isolated nitrogen 14. See? So even if he was saying, no, we actually like put this through a mass spec and found carbon-14, like there's ways for it to get there. So if you understand these processes, which I have to think he does, because I don't know how you get a PhD in geology and not understand like how to make carbon-14. Either you went to a really, really terrible PhD program and should absolutely get your money back, or he's being intentionally dishonest. Like those are the only pathways that I can see. So let's see how they try to turn a foe into a friend and still can't get 6,000 years. Should we give that a shot? Should we see how that goes? I think we should.
If radioactive decay was grossly accelerated during the flood, then the radioactive ages, though inflated, should still yield relative ages in the correct order. What do I mean by that? Well, think about a volcanic rock layer that formed in the first month of the flood. It would go through much more accelerated nuclear decay than a rock layer that was formed in the last month of the flood, wouldn't it? The one at the bottom would have 12 months.
Oh, excuse me, sir. Okay, excuse me, sir, because we're talking about decay rates. Let's just talk about carbon. Order of magnitude 6,000 years, right? 6,000 years. The amount of decay you get in a 1 month versus 12 months, right, is nothing, right? God, it's nothing, right? That's 1 year compared to 6,000 is nothing. It's a blink. Not even as good as a blink dog. I would like a blink dog. So this is bad. This is a bad argument, and this is an argument like you have to assume your audience doesn't have any concept of long periods of time, right? Or any concept of like just thinking about orders of magnitude. So like. That's the only reason you would feel comfortable saying nonsense like this. You have to assume your audience is dumb. And that's also very frustrating here, right? Ugh.
Worth of accelerated nuclear decay, so it should give an older age, and the one at the top should only have a month's worth of accelerated nuclear decay, so only give a younger age.
Excuse me, accelerated nuclear decay, because that's a thing that can happen, apparently. I mean, in my Dungeons and Dragons campaign, right? Like, God.
See? We can turn it from being an enemy to being a friend.
No, you cannot. No, you, sir, cannot. Okay. I think I'm done with Mr. Snelling. Because with the good doctor, because I am gonna lose my mind if I don't stop watching that. Honestly, guys, about an hour is the length of time I can handle Young Earth Creationism. Do you guys have any questions, comments, concerns for me while we're having this lovely chat this evening? Once again, I was talking about this at the start of the stream, but there was that confusion with the different streams. I'll learn. Saturday, I'm going to do a 1K sub celebration live stream. It should be at 7:30 Central, 8:30 Eastern time. I know I've got Skylar Fiction and Dr. Josh Bowen from Digital Hammurabi have offered to help me out. So I'm very excited for that, and maybe I can get some more friends to come by. I found what I want to do on Saturday is a sneak peek. I found the Evolution Chick Track, guys. Evolution Chick Track, and I want to like do Chick Track theater with everyone. So I think that would be a blast. I don't know. I have a twisted sense of humor. Anyway, you guys are really, really wonderful humans, and I so appreciate you coming to hang out. And I think I'm just good rambling, so I think I'll sign off. I might be done with radiometric dating for a while. I might jump onto a different argument. I found a Genesis Apologetics video on distant starlight, so I'm excited to see how bad that is. But yeah, okay. I'm gonna stop talking. Thanks, Joe. I'm glad. Fight the Flat Earth is such a nice guy. Like that was such a good conversation. And yeah, okay. So new climate video up on Sunday. Um, it's going to be on paleoclimate if I can get time to record that. And that's it. That's all my channel announcements. I need to sign off and stop rambling. So you guys are super cool. Have a great rest of your Wednesday. Bye, team.